All right, so as you move on in the equilibrium unit in Chemistry 30, the next part we would look at is Chateiler's Principles, which explains shifts of an equilibrium system and its graphs. So when we're looking at lechat, there are 3 stresses you can apply to any system that's in equilibrium. The first one being concentration, where you can add substances in or take substances out. If you add in, your graph shifts away. If you take it out, you shift towards. The other stress we can have is temperature, and this is the same idea. If you add temperature in, heating it up, you shift away. If you take it out, you shift towards. With temperature stresses, you would need to know if your system is endothermic or exothermic. So sometimes you might have to add in some Hess's law short to figure that out. And the last stress that we have only applies to gases or systems that are all gases, and that's a pressure and a volume stress. And that is if you increase the volume, you're going to move to the side with more moles. So this depends on there being a difference between the moles within the system. And just remembering that if you're increasing the volume, it means you're decreasing the pressure. And then the last part, just in terms of the theory, you can stress a system, but your system will always shift to alleviate that stress. So if you're increasing the concentration, your system shifts to decrease the concentration, and so on. Now, here's an example of a combustion reaction in equilibrium. This probably wouldn't happen being in an equilibrium, but we can force it and still take a look at what's happening. So in our combustion reaction, it's asked what would happen if you increase the concentration of oxygen. So oxygen's over here. If we add it in, you shift away. So we would shift to the right. If we removed oxygen, so taking it out of the system, you would shift back to replace it. The next part, what would happen if you decreased carbon dioxide? So if we added it in, we'd shift away. If you take it out, you shift towards. So this is another shift to the right. Next one, what would happen if you cooled down your system? So it's an exothermic reaction, so you would have energy on the product side. Mostly students understand heating up the system, so let's look at that first. If you added in heat on the right-hand side, you would shift to the left. So then the opposite is true. If you're cooling down the system, you are removing energy, so you have to shift to replace it. So this is another one where you would shift to the right. Now, the last one is what would happen if you decrease the volume. So if we're decreasing the volume, we are looking at all those moles, and we have more moles on the right-hand side than we do on the left-hand side. So if you're decreasing the volume, you're moving to the side with less moles. So in this case, we are going to move to the right, to the left, and that would mean you are shifting to the left. So that's our basic shifts. And then what we see is that every system in equilibrium, if you apply the stress, has a certain point in the graph that will always look the same. So if you have a concentration stress, you have one vertical line. If you have a temperature stress, you have no vertical lines. And if you have a pressure or volume stress, you have all vertical lines. So just going over that, you already know your system is in equilibrium because you have all horizontal lines. And then if you just have one of those lines going up, it's concentration. Temperature, the whole system has to heat or cool, and that can't happen suddenly. That's why we have no vertical lines. And pressure and volume changes, that does happen suddenly. That's why we'd have all vertical lines. So looking at this example with that same reaction, in this one, we just don't have water included as it is a pure liquid. So we just have our gases showing. We know that the reaction has started at the beginning and then equilibrium has been reached because it's horizontal lines. If we were analyzing and describing the stress and the time, at 5 minutes, we are adding in some product. So we would be adding in CO2. If you add in CO2, you're going to shift to the left. So the CO2 is going to be used up. And as we shift to the left, you're making more reactants. So that is our first stress. A concentration change at 5 minutes. Now equilibrium is reestablished because you have all those horizontal lines, and at time, it looks like this would be 9, you have all 3 vertical lines. If it's all 3 vertical lines, that is showing us that we have a volume or a pressure change. And then based on this, if it looks like we're producing more of the product and the reactants are being used up, that's showing me that we are shifting to the right. So we can figure out that stress as well. And then we've reestablished equilibrium with those horizontal lines. And then this last stress, you have at, we'll say 11, 12 seconds, you have no vertical lines, just this gradual change coming. So that is going to be a temperature stress. And because your product is being used up and your reactants are getting produced, that is also showing you're shifting to the left. So it looks like if energy was on the product side, you would be shifting away. So those are the 3 types of stress we have, and the 3 graphs that go with, or the 3 changes in the graph that go with it. I hope you found this helpful. If you did, please subscribe. And if there's any other video I could do for you, just let me know in the comments. Thanks for watching.